Welcome to my video on 13-2B trig review. Today we will be evaluating trig functions given a point on the terminal side. To do that, we do have to review a little bit of geometry, specifically the trig portion. So we're given right triangles. Everything we do for this will be based off of right triangles. I'd like for you to take a second to label the right triangle with the following names: hypotenuse, adjacent, and opposite. Okay, so on this first right triangle in the blue, we are given a theta. Theta is what we use to represent an angle. Okay, we know this is a right triangle because of the square in the bottom corner. So now, what is common to all right triangles is that the side that is opposite the right triangle, the right angle, will always be called our hypotenuse. So if you can identify the right angle, you can identify the hypotenuse. The other two sides will switch based upon what angle you are looking at. So if we are looking at this angle theta right here in this corner, our opposite side will be the one that is directly across from it. So we can label this side with opposite. The side that is attached to the theta will always be called the adjacent side. Okay, so you know there's two other angles in the triangle. This can flip-flop, so you always want to make sure you can identify your right angle first and then your theta. So if we're looking at this flipped triangle, right, the side opposite my right angle is my hypotenuse. The side opposite the theta, we're going to label opposite. And the side attached to my theta will be my adjacent. Okay, so these three names you need to be able to label in order to do everything we need to do with trig. Okay, so hopefully, as a review, let's try to remember what SOHCAHTOA means. Okay, what does SOHCAHTOA tell us? Well, this is just a trick or a way to help us to remember the three primary trig functions and their relationships within the right triangle. Well, what do I mean? Well, we have three main trig functions. We have sine, we have cosine, and we have tangent. Okay, so the SO, the CA, and the TOA stand for the sine, the cosine, and tangent. The O, H, and A stand for the sides of our right triangle. So O will always stand for opposite, H will always stand for hypotenuse, and adjacent will always, A will always stand for adjacent. So is basically saying that the relationship sine is equal to the opposite over the hypotenuse. Then we break down to the CA. The C stands for cosine, is equal to my adjacent over my hypotenuse. And my tangent is equal to my opposite over adjacent. So if we look at this as a fraction, if we have a defined theta, sine will be our opposite over hypotenuse, cosine will be our adjacent over hypotenuse, and tangent will be our opposite over adjacent. So to remember that, we remember the phrase SOHCAHTOA. Okay, so if you need that for a particular triangle, this is one last way of looking at it, right? Whatever the measure of that side is, we're going to fill into the fraction. So if this was a 3, 4, 5 triangle, right, my sine would be 3 over 5. My cosine would be 4 over 5. And my adjacent would be my tangent would be 3 over 4. Okay, so that's how we work with these primary trig functions. Okay, so now how does that relate to what we did in the last video? Well, let's start off by reviewing that a little bit. Let's let 3, -4 be a point on the terminal side of an angle in standard position. Okay, so if we remember, standard position means that the initial side is in line with my positive x-axis, my vertex is at my origin, and my terminal side is the side that swings out. So in this case, we need this to be going through the point 3, comma, negative 4. 3, comma, negative 4. Okay, so that is the angle that we would have in standard position. Okay, so now what I'm going to ask for you to do is, in part B, draw a vertical line from the point to the x-axis. So let's do that. From my point, if I draw a vertical line, which we know doesn't exist, which is why I'm making it dashed, okay, to the x-axis, what I'm actually doing there is I am creating a small right triangle, right? Because that's like an altitude creating the right angle. And the theta we're going to be looking at is the one inside, right? The one being made with our vertex. So I have turned an angle in standard position into a triangle. Okay, and now what are we going to do with that triangle? Well, you can bet we're going to use it to evaluate our trig functions. So now, in order to be able to do that, we need to know how long our sides are, right? Because all of the trig functions are based off of the relationship between the sides, right? So we know that this side right here is 3 boxes long. So the measure of that side is going to be 3. We know that this side right here is 4 boxes long. However, it is 4 boxes in a negative direction. So what we're going to label that side with is a negative 4. Now, the sign is going to be really important because this can happen in any of our quadrants. So if we want to differentiate between being in quadrant 1 versus 2, 3, and 4, we need to make sure we have our signs correct. So what's left for us to find in order to be able to do all the trig functions? Well, we need our hypotenuse. Now, hopefully you recognize that this is a 3, 4, 5 triangle. If you don't, remember we can use the Pythagorean theorem, which is a squared plus b squared is equal to c squared, to find what my hypotenuse would be. So 9 plus 16, we would get 5 is equal to c. All right? So we have all the sides. Now we can find our sine, our cosine, and tangent for this theta value. So sine is going to be opposite over hypotenuse. So looking at our theta that we have right here, my opposite value is negative 4. My hypotenuse is 5. So for this particular triangle in this particular location, my sine is equal to negative 4 over 5. Okay, notice the negative as an important value. My cosine, which is my adjacent over hypotenuse, is equal to 3 over 5. And my tangent, which is my opposite over my adjacent, is equal to negative 4 over 3. So we were able to evaluate the sine, the cosine, and tangent just by drawing a picture, identifying our angle, and making triangles. But you should notice, right, that these ones have some signs assigned to it, okay? And that's because of the quadrant we're in. So we'll talk about that in a second. But let's see if we can come up with a little trick. And the trick that we're going to come up with is that these sine, cosine, and tangents are always going to be associated with our x and y values, right? So if we're given a point and we can identify the x and y, we can identify our sine, cosine, and tangent by first plugging them into the Pythagorean theorem and finding the third side, and then plugging them into these formulas, right? So if this was the point, I don't know, negative 4, comma 6, right? My y value being 6, my x value being negative 4, my sine would be 6 over negative 4 squared plus 6 squared is equal to r squared. That's 16 plus 36. That's square root of 52, because that's equal to 52. Okay, so my r value in the denominator would be a radical 52. For cosine, it would be my x value, negative 4 over radical 52. And my y over x would be 6 over negative 4. Okay, now we should be reducing these. All right, so if you don't remember, let's talk about it again. If we have a radical in our denominator, we need to make sure that we rationalize it. So 6 over radical 52 can be rationalized by multiplying by radical 52 over radical 52, leaving me with 6 radical 52 over 52. Now we want to make sure every fraction is reduced to lowest terms, so both of these are divisible by 2. So our final answer here would be 3 radical 52 over 26. Okay, and same thing here, we would rationalize here, and we would reduce this to a negative 3 over 2. Okay, so let's put this into practice. Let's try a question. So an angle theta is in standard position, meaning it has this as its initial side, and its terminal side passes through the point negative 2, negative 1. Okay, so that is the angle that we're looking at. Find the exact value of sine. So let's zoom in here for a second. To be able to do this, we have to make that little triangle with our x-axis. So if I draw a line from my point to my x-axis, I now have created a little right triangle. The theta being the angle measuring with the x-axis, the right angle here, okay? And the sides corresponding to their x value of negative 2 and y value negative 1. So what are we looking for? We're looking for sine. So let's pick a different color. Sine of theta is equal to my opposite over my hypotenuse. Well, I'm going to need to find my hypotenuse by doing the Pythagorean theorem. So negative 1 squared plus negative 2 squared is equal to c squared. That's 1 plus 4. 5 is equal to c squared. So c is equal to radical 5. Okay? So my sine is going to be equal to my opposite, which is negative 1, over my hypotenuse, which is radical 5. If I want to make sure it's in the most precise format, I rationalize. So sine of theta is equal to negative radical 1 over 5 times radical 5 over radical 5, giving me a final answer of negative radical 5 over 5. Okay. And that was all done by turning this angle into a right triangle and finding all the corresponding sides.